Hello. So this first lesson is not actually a pre-calc lesson, but since it's been so many years since you've probably seen some problems, we need to review this. So in this lesson, we're going to recover some information about how to calculate distance, midpoint, slope between 2 points, and then a little refresher on how to graph some lines. So let's talk about distance. Distance on the coordinate plane, because there's two directions, x and y direction, we have a formula, which hopefully your geometry teacher had you partially memorize, if not all the way memorize. And the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm not real big on memorizing formulas because I don't have a really great memory for things like that. So I try to memorize what they're doing and why that formula is what it is, because then I don't have to think real hard. So when you're measuring distance between 2 points, it's essentially a Pythagorean theorem question. So for instance, if we were trying to find the distance between, throw some points out here, 2, 3, and how about -3, -1. So if I plot the point 2, 3, 2, 3, and then -3, -1, and I want to know how far apart these points are, what we could do is we could create a right triangle. Because if you look at this picture set up for a right triangle, the distance is the hypotenuse of that right triangle. So vertical and horizontal distances are very easy for us to either visualize or calculate. When I look at the horizontal distance here that goes from this point to this point, it's measuring 5 units. And then the vertical distance goes from this point to this point, it's measuring 4 units. And then if I do a little Pythagorean theorem, we would set up 5 squared plus 4 squared, and then to find the hypotenuse, you square root that sum. So I could have given myself one that worked out nicely, but 25 plus 16 is the square root of 41. So that would be the distance between these 2 points. Now let's look at the formula for distance and see why that's exactly what we just calculated. So when it says x2 minus x1 squared, that is you measuring the horizontal distance between your 2 points. So when you look at your x values, the distance between 2 and -3 is 5 units. It doesn't matter which order you subtract in because you're going to square that subtraction problem. So either way, it turns out to be a 25 right here. And then for the y's, y2 minus y1 would be the vertical distance between these 2 points, which is exactly what it says right here, y2 minus y1. So then the vertical distance between a 3 and a -1 is 4 units. So 4, -4 doesn't matter, it gives you 16. And that's why using the distance formula or thinking of it as a Pythagorean theorem question, they both work out the same. Now for me, remember I don't like formulas, I think of it as the distance in the x direction squared, and the distance in the y direction squared. So again, it doesn't matter if you incorporated the negative into the problem because you're going to square whatever that number is. So when I do some examples of distance, you're going to see me basically take a little shortcut, and that's exactly what I'm going to do. So here, the distance between my x's, if I think about a number line, you know, -8 to 4 is 12 units. So regardless of the order in which you came up with that 12, it doesn't matter because we're about to square it. And I always leave off negatives because it makes my calculations a little easier. And then for the y's, the distance between 3 and 6 is 3. So then we're going to calculate. I'd probably type a calculator, but get mine out right now. So what is that? Square root of 153? And then I already keyed this up, guys, but a decimal answer in some cases is very appropriate. Like for instance, here it says round to the nearest 10th place. That'd be a 12.4 when I type that on my calculator. Otherwise, your geometry teacher might have had you reduce these radicals, or maybe your algebra 2 teacher. And surely your PreCalc teacher will want you to be able to figure out any perfect squares that are divisible into 153. So I think 9 is, because if you add up the digits, 1, 5, and 3, yeah, that adds up to 9. So that means we could divide 153 by 9. So a little bit of calculator help here. It's 9 times 17. So another non-decimal answer would be 3 squared to 17. Depending on what the nature of the problem is, if it's an application problem or a real life problem, a decimal would make sense. In this case, the direction said round if you need to. But you know, we're PreCalc, we can reduce radicals if we have to. And the SAT test often will leave things in perfect form, like 3 squared to 17, because there's a no calculator section. And it's pretty difficult to hand calculate the square root these days. No one does that anymore. So let's do this next question again. I'm going to kind of cheat here and say the distance between the x's from -3 to -2, either order, is a distance of 1 unit, so 1 squared, plus a distance from 5 to 4 is, this is boring, 1 squared, so this is 1 plus 1, which is the square root of 2. So that would be an exact answer. Typing this on my calculator is roughly 1.4. So depending on what you needed from your teacher, either answer is great. So that was distance. Let's talk about midpoint. Midpoint, again, I'm really terrible with formulas, so I think of this as what it is, and it is finding the average point. So if you're finding the middle of two things, you're finding the average of them. So if you think about the midpoint formula, it is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And that's exactly how you would average two things. It's the average x value, because you add them up and divide by 2. And then it's the average, whoops, excuse me, get out of there, average y value. So again, if you're really bad at formula memorization, just try thinking about what they mean. They're really not that complicated. I think I could go through an example, I guess. I don't know. Didn't we have some points on the other one? Let's steal those. Wasn't it 2, 3, and -3, 1? -1, excuse me. So ordered pair at 2, 3, and then -3, -1. And I could visualize where the middle would be, I mean, even if my cruddy drawings, the middle is somewhere over here. So if this is like a multiple choice question, I might be able to just kind of visualize where the midpoint is given the 4 choices. But we should be able to calculate that. So remember, this was the ordered pair 2, 3, and this was the ordered pair -3, -1. Woo! So if I'm trying to figure out the location of this little star, I'm going to look at the x's first. It's halfway between -3 and 2. So using my midpoint formula, -3 plus 2, then averaged would be -1/2. And then, same thing for the y's, -1 to 3, halfway between there, would be 2 over 2, which is 1. You know what? I graphed really poorly, but that was pretty good. Good, go me. All right, so this next set of questions is just executing that formula. So we're going to average up the x's, average up the y's, and if the answers come out to decimals or fractions, I'll accept either answer if the application doesn't say what they want it as. But if you're graphing, sometimes decimals make more sense in certain instances, so it's up to you. Here, the x's, negative, average together, and the y's average together. So when I calculate that, 8 plus -4 is 4 over 2, which is 2, and then 0 over 2, which is 0. So the midpoint between those two ordered pairs is 2, 0. Using that same formula, averaging up my x's. Most common mistake on this question, most common is not knowing the formula when you have to memorize it. Another common mistake is just execution of your arithmetic. A shame. Usually that's when I curse myself. I just say it's terrible to mess up, and then I'm going to mess up, so watch out. All right, 3 over 2, and then -4 over 2, which is -2. So 3 over 2 decimal equivalent is 1.5. So if I was trying to graph this or look at it from a graphical point of view, 3 over 2 is part of an ordered pair. Doesn't make a lot of sense, but 1.5 makes a little more sense. So either answer, I like them both. All right, slope. You probably know 5 definitions for slope. So let's come up with, first of all, they use m to represent slope in algebra. And I've been told that's just America that uses m. So whatever. The formula for slope is y2 over y1, or y2 minus y1 over x2 minus x1. However, the subtraction of the y and x coordinates, if you flip the order, that's fine as long as you maintain that same order. So you could do y1 minus y2 over x1 minus x2. The idea for slope, though, is it is a rate of change. So it's telling you how far, in what ratio is the y changing versus the x. So for a lot of little kids, they learn the formula of rise over run. This is a cutesy way for you to remember to go up and down first. The more advanced notation for rise over run is, it's called a delta symbol. It's a Greek letter. So change in y over change in x. So remember that delta means change in. They use delta a lot in the applied sciences. There's a lot of different ways you can remember slope, so just pick one, I guess. Most kids just go back and go to this formula because they like formulas, believe it or not. All right, so if I come up with the same two ordered pairs that I was using earlier, which was 2, 3, and -3, -1, it doesn't matter. But if I plot those 2 points, 2, 3, and then -3, -1. When you were first learning about slope, you were also learning about how to graph ordered pairs. And a lot of kids confuse the two because when you graph an ordered pair, you move horizontally for the x coordinate and then vertically for the y coordinate. But then when you think about slope, you have to remember to count the vertical change over the horizontal change. So be careful. And remember that slope is the rate of change, rise over the run, the change in y over the change in x. So I usually start at the bottom lowest point, and then I figure out how far up it went. So it went up 1, 2, 3, 4. That's up, so it's a positive movement. And then to the right, 1, 2, 3, 4, 5. And then remember slope, represented as m, is the change in y over the change in x. And then if that reduces or simplifies in any way you want to do that. Slope we like improper fractions if they come out to strange mixed number decimals. But 4 over 5 is a good answer for this one. So a few examples here. You just watch who is your x and y. Just remember that the first part of the ordered pair is the x. The second part of the ordered pair is your y. So change in y, any order, does not matter. I'm like old school, so I always go like y2 minus y1. So 8 minus 13 over, watch your negatives, -4 minus a -16. Now, I suffer from pretty significant dyslexia, so I make a decision, depending on how I'm feeling. I either go through the formula very carefully and double check my negative work, or instead of actually calculating it, I visualize it because that's a little easier for me. Because I can visualize distance a lot easier than I can do negative calculations because of the way my brain works. So you decide what works for you. As long as you're accurate, I don't care. 8 minus 13 is -5. And then these negatives become plus. So it's -4 plus 16, so 12. And this slope does not reduce any further, so -5 over 12 is a good answer for me. I'm going to show you what it looks like when you visualize slope as opposed to like calculating it. So I go back to my rise over run formula and I think about, I have to stay consistent with my order, right? So if I go from a 17 to an 11, for me, like I visualize that as lowering 6 units. That'd be like a -6 for me. And then if I go from a 15 to a 1, that's again going negatively backwards 14 units. So that reduces to a positive 3 over 7. So you have to kind of decide where your brain fails you. If it does, maybe you don't have any problems with slope. But like I've learned from many, many years of calculations that like while I totally know what I'm doing, I gotta be really careful. So think about that. All right, so graphing line. We have our favorite line form, which is y equals mx plus b. This is called slope-intercept form. And oops, we probably already learned a lot of this in Algebra 2. Math people name things for exactly what they are. So the reason this is called slope-intercept form is because when it's in this form, you could easily identify the slope, which is m, and the y-intercept of the graph, which is b. So when you're graphing, if you recognize it's in this form, you can go ahead and pick up slope and intercept and graph. We always want to start with the y-intercept though, and this one's kind of weird because it doesn't seem to be one, so remember that just means it starts at 0. So your y-intercept is where it crosses the y-axis right there at 0. And then your slope is 4, but remember slope is a rate of change, so you always have to interpret it as a fraction because you need rise over run. So +4 over +1 would be up 4, right 1. You could also move -4 over -1. That would give you the same rate of change because negative over negative is positive. Now, if this was a perfect world, I would be connecting these lines. But I'm on my tablet. It's really hard to graph a line. So can you just imagine what would happen if I connected? All right, number 11. It is in slope-intercept form, so we're going to start at the y-intercept at 3, and this time your slope is a negative ratio. So the negative has to either go with the 3 or the 2, not both at the same time, because that would be positive. So I'm going to start it off as negative 3 over 2 for rise over run. So rising negative 3 would be going down 3, and then running positive 2 would be to the right. So the last thing I would do after I pretend I graph the line, I think about a positive slope line versus a negative slope line. And I kind of step back and I go, yeah, that's totally going to be a negative slope line. I must have done it right. All right. Next one's a special case. It's not in what we consider slope-intercept form, but that's because there is no y value in this line. So this is a special case of a line. And special case just means it's a unique line. It's either going to be vertical or horizontal. So a lot of kids confuse this with the axes. X equals 2 is actually a vertical line through x equals 2. So like here's x equals 2, right? So if I draw a line through this, all right, there we go. So the idea with this line is that any ordered pair I picked up off of it would have the x value as 2, and then the y value would be, you know, whatever it was, however high or low it was on the line. So 2 comma 4, 2 comma negative 8, 2 comma 3, 2 comma 0, 2 comma 1.35. Those are all the points that make up the line x equals 2. But this next line is not in slope-intercept form. You have two choices. You could either rearrange it so it is in slope-intercept form, or you could graph the x and y intercepts. So for me, I don't care. Typically, I graph the x and y intercepts if I notice they're nice. So if you think about what an x-intercept means and what a y-intercept means. An x-intercept is where the line crosses the x-axis. So the ordered pair down here is going to be something, comma 0. So that's how I know it's an x-intercept, is because the y value is 0. And then vice versa for the y-intercept. I know the y-intercept is going to be something along here, which means the x has to be a 0. So these are pretty easy to find if you have some nice coefficients. For the x-intercept, if you were to plug in or substitute in a y equals 0, this whole term would be like gone. You just look at the equation, x equals 6. And then you're going to do the same thing for the y-intercept. Without rearranging, you could just be like, pretend that's 0. So when you have a little bit of work, 2y equals 6, which means y equals 3. So it's a way of finding two ordered pairs. And if you think about the definition of a line, it's what connects or goes through 2 points. So as long as you have two ordered pairs, that's enough for you to graph. So 6 zeros are here, 0, 3 is right here. And then again, use your imagination and pretend I like totally connected that and made a line. So if you don't like isolating variables and rearranging the equation, you know, that's an option. So remember a couple examples ago, we had x equals 2 and it was a vertical line through 2. So in this case, it's y equals negative 3, which means opposite of that. So through the y-axis, here's negative 3. And then we'd, missed. All right, pretend that it's totally horizontal, which means every single ordered pair here is going to have a different x value, but every single y value is going to be a negative 3. So like 1, negative 3, 0, negative 3, 5, negative 3, and so on and so on. Again, a special case, but not difficult if you remember. So again, on 15, you can either rearrange this into slope-intercept form, or you can do the x and y intercept method. So let's practice that intercept method a little more. I feel like that is one of the things we don't get to do a lot of in algebra. So for the x-intercept, that would be when y is 0. So pretend that doesn't even exist, that y term. So you get x equals negative 3. And then, similarly, get rid of the x term. So careful, little math. Negative y equals negative 3, which means y equals positive 3. So if I plot these 2 points, negative 3, 0, and 0, 3, then so close, connected. There you go. Another way to graph a line. So ignore that slide. That would be the end of this lesson. We have a follow-up lesson where we're going to continue to talk a little bit about graphing, but more importantly, we're going to be able to now write equations and functions for linears. We're going to eventually move on to applications of linears. So hopefully that is a nice stroll down memory lane for y'all.